Determine the distance of the point having coordinates 3, 5 from the line whose equation is 2x plus 3y equals to 14, and it is measured parallel to the line x minus 2y equals to 1. Okay, let us try to understand the problem graphically first. So in this problem, what we have here is the point A with coordinates 3, 5. We have a line with the equation 2x plus 3y equals to 14. That's the line L. So our goal will be to determine the distance of this point A from the line L, but it must be such that if we, let's say, join point A and the line L with the help of a segment such that this line segment, let's say it meets the line L at B, then AB must be parallel to another line L prime whose equation is given by x minus 2y equals to 1. Okay. So here, what we'll do, we are going to use the distance form of a line to find out the distance AB. Okay, so let us suppose that the distance AB, that is R is what we need to find out, and we will suppose that the coordinates of the point B be x, y. Now, what we'll do here, we're going to use the distance form of a line. Now, we can use the distance form. That is because to apply the distance form, the line must pass through 2 points. So here we have the line segment AB passing through the point A with coordinates 3, 5 and the point B with coordinates x, y. That means according to the distance form what we have here. Now here, while applying the distance form, we need to be careful with the position of A and B. Clearly the x and the y coordinates of A, they are greater than the x and the y coordinates of B, since it lies to the right of point B. So here what we'll do, we're going to take the difference of the x coordinate. We'll take 3 minus x divided by the cosine of the angle that AB makes with the x-axis. So let us suppose that that is the angle alpha. That is going to be equals to difference of the y coordinate. So we have 5 minus y whole divided by sine of the angle, that means the line makes with the positive direction of x-axis, and this is going to be equals to r. Okay, so what we can do here is we can rewrite this as 3 minus x over cosine of alpha equals to r, or we can say 5 minus y divided by sine of angle alpha, that is also equals to r. So let's isolate x and y from both sides. So we are going to get 3 minus r cosine alpha, and y is going to be equals to 5 minus r sine alpha. So here what we have done, we have expressed the coordinates of the point B, which are taken as x, y, in its parametric form. So the 3 minus r cosine alpha, which is the coordinate x, so that is the parametric form here. Similarly, y expressed in the parametric form as 5 minus r cosine alpha. So here r is going to be the parameter. So we can say that the coordinates of B, they are going to be expressed in the parametric form as 3 minus r cosine of alpha, 5 minus r sine of alpha. Now the next question is, what is the value of cosine alpha and sine alpha? We can obtain that because we have the equation of L prime, which is x minus 2y equals to 1. Now from this equation of the line, we can find out its slope. So we have ML prime, that is going to be the slope of the line. If we consider AB to be the slope of the segment AB, clearly two parallel lines have got equal slope. So that means whatever be the slope of ML prime, that is going to be the slope of MAB as well. So let's try to find out the slope of ML prime taking the help of the equation x minus 2y equals to 1. We have L prime with the equation x minus 2y equals to 1. So we're going to rearrange the terms. We're going to keep terms containing y on the left hand side and all the terms containing x on the right hand side, including the constant coefficient, which is 1. So we had 2y equals to x minus 1. So we are going to divide both sides with 2. That's going to give us half x minus 1 half. So if we now compare, so we are going to compare this with comparing with the slope-intercept form. Comparing with the slope-intercept form, y equals to mx plus c. What we get? We get the slope of this line. So we are going to get m. M is nothing but the slope of L prime. So that comes out to be equals to 1 half. But we know that ML prime, equals to MAB as well. Since we can say that L prime, the line L prime is parallel to the segment AB. So this implies that means the slope of AB, the line segment AB, that is also going to be equals to 1 half. Fine. Now what is slope? Slope is usually defined as the tangent of the angle that the line makes with the x-axis. So let's say that angle is also alpha. So that means this is going to be 1/2. Why is it alpha? Let's quickly go to the diagram. Now look at AB. So if we extend the line segment AB along B, so this is going to intersect the x-axis. Now since they are parallel, now we have already considered this to be angle alpha. That AB makes an angle alpha with the x-axis, and since AB is parallel to the line L prime, so this is also going to be the same angle alpha. Fine. So that means we have tangent of alpha equals to 1/2. Now using tangent of alpha, can we not find out the value cosine alpha and sine alpha? So let us consider the right angle triangle, which is right angle at B, and angle C, that is the acute angle alpha. Now what is tangent of alpha? Tangent of alpha is simply the ratio of the opposite, which is AB, to that of the adjacent, so that's BC. So the ratio of AB to that of the side BC, that's 1 over 2, or we can say that AB corresponds to 1 and BC corresponds to 2, and when we apply the Pythagoras theorem, then the hypotenuse must become square root of 5. Now that we have the length of each of the three sides of the triangle, so we can easily define sine of angle alpha as well as cosine of angle alpha. So sine of the angle alpha, that is the opposite, which is AB, to that of the hypotenuse AC. So sine alpha corresponds to the value 1 over square root of 5. Then we need cosine of alpha. So cosine of alpha is going to be the ratio of the adjacent BC to that of the hypotenuse AC. So we get cosine of alpha equivalent to 2 over square root of 5. So now we have successfully obtained the value of sine alpha and cosine alpha, which means that we can now express the coordinates of B as, so we're going to replace cosine alpha and sine alpha with their respective values. Now the next task will be to determine the value of R. So what we can do here, we can use the fact that if we go to a diagram, we can see here that the point B, whose coordinates that we found out just now, it is going to lie on the line 2x plus 3y equals to 14. In other words, we can say that this point is going to satisfy the equation of this line. Now what we'll do, we will take 2 times x, but in place of x, we're going to replace it with the x coordinate of the point B. That's going to be 3 minus 2 times r over square root of 5. This is going to get added to 3 times y, but y will be replaced with the y coordinate of the point B. So we have 5 minus r over square root of 5. This is going to be equals to 14. Once we solve the equation, we're going to get the value of r. So let's do that. We'll first distribute 2. That's going to give us 6 minus 4r over square root of 5. Added to, so distributing 3 gives us 15 minus 3 times r over square root of 5, and this is going to be equals to 14. Okay, so now we have here is 7r over square root of 5. That's going to be equals to 7, and solving for r, we get r equals to square root of 5. So here, what is r? We initially considered r to be equals to the segment AB. So we have successfully obtained the length, the distance between the 2 points A and B. So that's going to be equals to square root of 5 units. We can say thus the distance between the 2 points AB, that is going to be equals to square root of 5 units. So that is our final answer.